putting together a simple micro lecture, getting you to understand how to calculate individual target heart rates for clients, and we're talking about using the Gellish et al. 2007 equation or model. And that is located, if you're doing the exercise referral, that's located on page 32 of the booklet. So the objectives of this micro lecture is getting you to understand the development of methods to estimate training intensities. First of all, we're going to make reference to the Fox et al. 1971 model or method, and the original equation that we've heard about before is the 220 minus your age, and that was sort of hypothesized and developed by Fox and colleagues. And then we're going to look at another one, we call that the Karvoen's method, and that was developed by Karvoen with the help of others in 1988. And that was one of the ones that in level 2 qualifications is generally established. But with anything, there's evolution in science, and we're starting to look at different models. And the one that we use in the right foundation is the Gellish et al. 2007 equation, sometimes referred to as the heart rate reserve model. So that's the one that we're going to use, and I'm going to just take you through some worked examples of it, just to help us to try to conceptualize and understand how to calculate these. Possibly in the real world, we might be able just to download an app and it does the calculations for us, but when we're looking for assessment purposes, we have to demonstrate, a bit like any other science, that we can do the old sort of calculations manually. So let's have a look at it. So we've all heard about this in secondary school and higher PE or whatever else, the 220 minus your age. And when I started to dig a little bit deeper, we started to look at where the evidence derived from. So the original equation was based on the data. It was compiled by Fox and colleagues in 1971. But most importantly, it was actually only intended to be a rough formulation based on the apparent decline of the maximum heart rate with age from the studies that they looked at. The individuals that was examined in the research referenced by Fox and colleagues, it was never meant to be representative of the whole entire population. Within the studies, they actually were all male. Most were under 55 years of age, and the data from the studies was sort of conducted in different sort of settings and various conditions. So it had sort of issues with the quality and consistency of evidence. Tanaka et al., and I think it says in the exercise referral book, that's what that was cited for. And so this sort of questions the validity of using this formula. So furthermore, even Fox and colleagues speculated that the actual rate of decline in the heart rate max with age for the population would likely prove to be somewhat less than that was suggested by their own experimental conditions and equations. But most importantly, the heart rate max prediction model of 220 minus their age has actually become ingrained and stoned, and it's been well established in the fitness literature as well as the medical literature, and is used widely in clinical and fitness settings, but the validity of it is sort of really uncertain. But we had to start somewhere. So the Fox equation has been reported to have like deviations or sort of not been that reliable, with the standard deviation of it could be as far as 10 to 12 beats per minute out. So when estimating heart rate max, we're using this equation, the Fox equation. Approximately 66% of the population actually falls between 6 to 10 beats per minute of the actual heart rate max, but for the rest of the population, it could be as far out as between 12 and 20 beats per minute. So the Fox equation, or the 220 minus age equation, isn't the most reliable, but we actually have to understand at least where it came from and what the intended purposes were. So we're going to fast forward on just a little bit, and we're going to look at another founding father scientist called Karvoen. So Karvoen, or Marty Karvoen, he was an exercise physiologist, and we sort of, until his passing, he was considered a founding father of cardiovascular epidemiology and prevention in his native homeland in Finland. He got his PhD from Cambridge University, but he was actually brought up in Eastern Finland, and that sort of defined his approach to cardiovascular medicine. So he sort of observed, and it became apparent to him that many of the men that was coming back from the Second World War in his area were dying of heart disease. And he noticed that the local diet was rich in calories and fat, and observed that the serum cholesterol levels in men from Eastern Finland were higher for those in Western Finland. So he became really fascinated and interested in understanding the reasons for cultural differences in cardiovascular event rates and the role of diet in the development of atherosclerosis. Then we're going to look at some other interesting work that he actually did with his colleague. And it actually involves something we use all the time. And it was looking at heart rate monitors and telemetry straps and continuous ECG recordings. So what they started to look at is, can you look at the variations in heart rate during exercise, and can they relate to or correlate with changes of exercise intensity, and can you measure them with a radiotelemetry and continuous ECG reading? Think about polar heart rate monitors. So the heart rate has also been recorded in a memory of a microchip, which can be carried on the wrist as easy as a watch. Again, your heart rate monitors. So this little device in the heart rate transmits and receives information which it feeds to the watch. The original studies that Karvoen and his colleague were doing was looking at telemetry straps based on alpine skiers. So by recording the heart rate during the training sessions or a segment of training, and being able to calculate the average of the heart rate and comparing this average to both the maximum heart rate values of the individual and the resting heart rate values of the individual, we could start to develop a percentage workload that an individual could perform, given you training intensities. These results are useful in planning optimal training intensities for both the healthy and rehabilitating athlete. So the use of target heart rate as a tool for exercise prescription is now really common, and we've even got smart watches that do it as well. But it actually represents the percentage difference between resting and maximal heart values, and then we add that resting heart rate. So that was when we came up with this Karvoen method, which I'm going to show you. So when we look at the Karvoen method, and imagine you're looking at a typical 40 to 60% of the heart rate reserve added to the formula. So in 1971, we originally had the 220 minus your age, and then Karvoen came up with another formula in which we coupled the results from Fox, so we used Fox's results to calculate it. But as you've been aware, as I sort of said, Fox's results were slightly problematic and they weren't very consistent. So now we're going to look at another model, the one that we're going to look at within the logbook, and the one it could be potentially examinable. So we're going to look at the Gellish et al. 2007 heart rate reserve model, located on page 32 of the booklet. So Gellish in 2007 was sort of questioning the reliability and the accuracy of other methods of heart rate prediction. So the heart rate max values calculated by Fox, the 220 minus your age, versus those predicted by the linear non-linear age models, are sort of put up there on the graph for us. So what he got, or Ronald Gellish got, was he came up with an equation based on 206.9 minus 0.67 multiplied by age. All it is in your textbook is we've rounded it up, and it's 207 minus 0.7 age. And that standard formula that's better because the standard formula of 220 minus your age tends to overpredict the heart rate max for younger persons and underpredicts for older adults. So as a result, there are noticeable differences if we use Fox's model, especially at the ends of the age spectrum, young versus old. And that could be as far as at a 30-year-old only be 3 beats per minute difference. But in a 75-year-old could be up to 12 beats per minute different. And that's not including any contraindications such as medicine. When he started to look a little bit more, we looked at the statistical significance based in t-test statistics, etc., etc. It was actually, it was coming across that their model was slightly more statistically significant and sort of fits the curvilinear models. So we use the 207 multiplied by 0.7 of the age with it. So that's why we work differently. So let's have a look at the worked example. So the most important part, the Gellish heart rate reserve located on page 32. And what I tried to do to help us is just to indicate the key numbers, or the key numbers and where it relates to it in an equation, the old school equation. So we've got 4 steps to it, and I'm going to take you through it step by step, as they say. And it's not difficult when you can see where we just put these numbers in. So I was given a question. So the client is a 50-year-old with a resting heart rate of 80 beats per minute. And what I need to do is I need to calculate a low or light or low intensity training zone for them. So step 1, we need to calculate their heart rate max. And we use the Gellish model for that. So it's 207 minus, then in brackets, 0.7 multiplied by age. Let's look at it. So I've gave you a worked example. So the thing in red is what we need to find out first, and that's the age. So we need to find out the age, and he's 50-year-old. So to calculate the heart rate max, it's 207 and then minus, but we do the things in the brackets. So it's 0.7 multiplied by 50, which is the client's age. That gives us 35. So it's then 207 minus 35 will give us a maximum heart rate value of 172 beats per minute. I'll pause for a second and have a look at it again and just see what I've done. Do the things in the brackets first of all. Simple, easy. Step 2. We've calculated the maximum heart rate using the Gellish model. Now what we need to do is calculate the heart rate reserve. So what we do is we need to make sure from step 1 we've got that 172 beats per minute. And what we then do is we subtract that from the 80 beats per minute from the client's resting heart rate. Again, if you look up at the top, that 80 beats per minute I've identified in red, and I've just put it down there. So it's 172 minus 80 gives us 92 beats per minute. We have now calculated the heart rate reserve. Easy so far. Step 3. Halfway there. Now, on page 32 of the exercise referral booklet, what we've got to do is we've got to look at the training intensity we've been asked to calculate. So I've just took that over, and it's light to low. With the arrow, that's where I got the number 20 to 39. So that's 20% and 39% of the heart rate reserve. So I've got 2 calculations I need to do for this because I need to find the lower limit and the upper limit of light to low. The lower limit being 20 and the upper being 39. So how do I do it? So we take the heart rate reserve from step 2, the 92 beats per minute, and we multiply it by the 20%. Now, an easy way to do that is just multiply it by 0.2. So 92 multiplied by 0.2 will give me an 18 point something. We round it down, so it gives us 18 beats per minute. Then we need to calculate 39% of the resting heart rate value. So it is 92 multiplied by 0.39, and it gives me 36 point something again. Round it up or round it down, it gives us 36. That's as calculated the light to low intensity training zone. That's step 3 done. Step 4, the last one. A little add up. So all we need to do now is add on the client's resting heart rate at 80 beats per minute to give the working range. So the 18, so the 20% heart rate reserve, plus the resting heart rate gives me 98. And then the 36, which is the 39% of heart rate reserve, we add that to 80, which gives us 116. That gives me a working target range of between 98 and 116 beats per minute for a 50-year-old client with a resting heart rate of 80 beats per minute, training at light to low intensity. So I'll show you the calculation just in summary and what we've done. So step 1, we calculated using the Gellish model or equation the heart rate max. Step 2, we calculated the heart rate reserve. Step 3, we needed to indicate from the table what intensity we were looking at, and that was looking at light to low, so 20 to 39% of the heart rate reserve. We came up with the lower limit and the upper limit of that spectrum. And then lastly, we added it with the resting heart rate to give me 98 beats per minute at 20% heart rate reserve. And then the upper limit at 39% of the heart rate reserve, 116 beats per minute. So the client's, that specific client's target heart rate is working at 98 to 116 beats per minute. It wasn't too difficult. Now there is a try this example on page 32, and what I thought I could do is help you a little bit more. I've not calculated out the equation, but what I've done is allowed you to look at this as a template and maybe fill in the blanks. So look what I've done for step 1. So I've got the equation, the 207 minus, so it's the 0.7 multiplied by the client's age. I've indicated that in the textbook it was 45. That gives you a number. Write it in. Step 2, need to calculate the heart rate reserve. So whatever you got for your heart rate max, you have to fill it in. And then you minus it or subtract it from the 75 beats per minute. That's in the textbook. So that was his resting or her resting heart rate. And that gives you another number. Now the bit that confuses a lot of people is the moderate intensity. Look at the arrow. Look where the arrow is pointing to. So you've got two little steps to calculate, one at 40 and one at 59. And then step 4, it's adding them all together. So hopefully this will be of use to you, and it'll allow you to stop, to pause, and to reflect on it prior to maybe getting an exam. But there's 4 very, very basic steps for allowing you to calculate the heart rate reserve Gellish model. Hopefully you found this to be of benefit. Remember, you can use this whenever you want, you can pause it, and you can continue. If you've got any other problems with this, because it's tricky, just don't be frightened to ask John or myself about it. So what I want to do is just thank you, and I'll see you again.